Welcome to the Woodbridge Geometry Virtual Tutor. You are working in the right triangles and trig unit. By the end of this, you should be able to solve for real-world problems to find missing angles or sides using angle of elevation or angle of depression with a right triangle. So let's start talking about angle of depression and angle of elevation. So let's recall some previous knowledge. So what do we do if we need to find an angle given two sides? So that means we have two side lengths, we're missing the angle. So anytime you're missing the angle, you're taking the inverse. Okay, you're taking the inverse of that trig function. So in your calculator, that's the second trig function. So if we were working with sine, the inverse of sine is sine raised to that -1, right? And same with cosine, we can take the inverse of cosine and the inverse of tangent. That gives us that -1. So what are the inverses used for? This is used to find an angle. So a lot of time you're going to hear angle of elevation or angle of depression. So, angle of elevation. This is the angle between the horizontal and the line of sight when a person looks upwards. So elevation, you're looking up. So if you're standing here, you know elevation means you're going up. Your horizontal is what your eyes can see at the bottom of what you're looking up, and the angle in between is the angle of elevation. And if you were to connect down from your line of sight to your horizontal, it creates a 90-degree angle. So that's why we can use trig, because we have a 90-degree, which gives us a right triangle. So angle of depression, this is the angle between the horizontal and the line of sight when a person looks downward. So that means that person is up top. So you're standing up high. You're looking down. Your horizontal is at the top. So between your horizontal and your line of sight would be the angle of depression. Again, if you were to connect down, it creates a 90-degree angle. So if we have a 90-degree angle, we can use the trig functions because we have a right triangle. At the bottom here, we're going to name the angle of depression or elevation in each figure. So in number 1, you are the person standing. So if you're standing, we see SW is a flat line. That represents your horizontal. Where you're looking tells you which way your angle's going. So if we're at W, we're looking up to T. So this is your line of sight. If you're at W looking up to that Ferris wheel, up to T, you know that's an upwards angle. So that's elevation. So this is an angle of elevation. So anytime you think you're looking upwards, that's elevation. Number 2, we're in that helicopter at point L. We're flying the helicopter. So from F to the helicopter, we know is a flat line. That's your horizontal. You're in that helicopter looking to land at point S. So you're looking downwards. That's your line of sight. The angle your horizontal and line of sight makes is the angle of depression because you're looking downwards. And we know that 90-degree is in front of you when you connect your horizontal and your line of sight. So what's important to notice here is when you're creating this triangle is the location of your 90-degree angle. So an angle of elevation, your 90-degree angle is at the bottom. So you have theta, we know this is your line of sight. Your horizontal is at the bottom. And your 90 degree is at the bottom. So you need to know 90 degree at the bottom. For an angle of depression, we know the horizontal is at the top. Your line of sight, you're looking downwards. And the angle they create is your angle of depression. So your 90 degree is at the top. So the 90-degree angle is at the top. So that's going to be important when setting these up. So 90 degrees at the bottom, it's angle of elevation. 90 degrees at the top, it's angle of depression. So the 90 degree is kind of opposite what you're thinking. So if you're looking upwards, your 90 is at the bottom. If you're looking downwards, your 90 is at the top. So let's go ahead and apply this. Example 1. A bird watcher spied a woodpecker on top of a 40-yard-foot tree. The distance between the bird watcher and the woodpecker is 175 yards. What is the angle of elevation to the nearest tenth? So first thing we need to think about is a picture. We want to get a visual down to help us. So we know the bird watcher spied a woodpecker on top of a 40-yard-foot tree. So that means that bird is up top. So if it's up top, it's an angle of elevation problem. So your 90 degree is at the bottom. So here's that bird watcher. The bird's up top here, flying away, or actually it's actually sitting in a tree, but that's okay. Here's a tree. That's beautiful. Okay, so if we look at that triangle, we now need to figure out where our labels are going. We know it's on top of a 40-foot-yard tree. So this tree is 40 yards. So that side of the triangle is 40 yards. The distance between the bird watcher and the woodpecker is 175 yards. So that's the direct distance between the bird watcher to your bird. So if we work with just the triangle, we found 40, 175. We need the angle of elevation. This goes back to trig functions. We need to think about our functions we've talked about previously. We have SO, CA, TOA. So labeling our sides, we're standing at that theta. The side across from us is our opposite. The side next to us is our adjacent. And across from the 90 is the hypotenuse. So based on that visual and that setup, we know we're working with O and H, your opposite and your hypotenuse, which comes from our sine function. So sine of theta equals our opposite over hypotenuse. We substitute right into our calculator after we plug in here. So we're going to have sine of theta equals our opposite, which we know is 40, all over our hypotenuse, which is 175. So at this point, we know we're solving for an angle. Since we're solving for an angle, you need to take the inverse. Anytime you're looking for an angle, it's an inverse. So go ahead and grab your calculators. And the first thing you want to do when you have your calculator is check to make sure you're in the correct mode. Anytime you're working with trig, your calculator needs to be set in degree mode, which is not your normal default setting, so you need to fix that. So if you identify where that blue second button is, right next to it is the mode button. Hit that. And you want to scroll down until radian is flashing and hit the arrow to the right and hit enter. And now it should be set flashing on degrees, so you're good to go with trig functions. So we need to take the inverse of sine here. So second sine brings us to that -1, and we just put in 40 divided by 175. And enter. So what is the angle of elevation to the nearest tenth? So 2 decimal places. So we said sine inverse here of 40 over 175. So theta came out to be 13.2 degrees. So it's kind of just applying everything we've done in trig into one problem and setting up a visual. So be careful on your setup. Number 2, a ski slope is 250 yards long with a vertical drop of 100 yards. Find the angle of depression of the slope to the nearest tenth. So the key in this problem here is angle of depression. So if we think back to our setup, angle of depression, we know we're looking down and our horizontals at the top. So that also makes our 90-degree angle at the top. It tells us we have a vertical drop of 100 yards. Vertical means up and down. That's like your y-axis on a grid. And the ski slope itself, so anytime we think of slope, we're thinking of change in y over change in x, or rise over run. So with that being said, that is your hypotenuse or the diagonal in this problem. So that slope is 250 yards, which is across from your hypotenuse. So if you're standing up at the angle of depression, the side across from you is your opposite, side next to you is your adjacent, and the side across from the 90 is your hypotenuse. So we know trig function, we need to identify, is it sine, is it cosine, or is it tangent? We have O and we have H, so that's going to sine. We're going to have sine theta equals opposite over hypotenuse. We don't know theta, that's the angle of depression, so we leave that blank. We know the opposite is 100, and we know the hypotenuse is 250. We need the angle, so anytime we need the angle, we take the inverse. So we're going to take the inverse of sine of 100 over 250. At that point, we go ahead and grab our calculator again. So we go ahead and put in second sine to give us the inverse. 100 divided by 250, and enter. This problem wants our answer to the nearest tenth, so we have 0.57, so we're rounding up. So theta comes out to be 23.6 degrees. Number 3, a tree casts a 25-foot shadow on a sunny day, as shown in the diagram below. If the angle of elevation from the tip of the shadow to the top of the tree is 32 degrees, what is the height of the tree to the nearest tenth of a foot? So this problem is nice because it gives you a visual and you don't have to set it up. So first thing we want to do is figure out what side of this triangle we are solving for. What is the height of the tree? So we can go ahead and put a variable on that tree. It doesn't matter what you put there as long as you realize that's what you're solving for. And we know we have an angle of elevation. So we're standing at that angle of elevation. The side across from you is your opposite. The side next to you is your adjacent. And across from the 90 degree is your hypotenuse. So we have to ask ourselves, where do we have all the information? What two sides? We know we need the height, which is our x, and they gave us the 25. So we have sine, cosine, tangent, so SOHCAHTOA. And then which trig function has an O and an A involved in it? O and A is coming from tangent. So we're going to have tangent of theta equals opposite over adjacent. We substitute in what we know. Tangent, theta is the given angle, so that's 32. is equal to your opposite, which we don't know, that's the height, so we put in a variable x, all over our adjacent, which is 25. So this problem's different than the other two problems we've done. Previously, we had to find the angle, that's the inverse. This time, we have an angle and a side. So when we have an angle and a side, what we want to do is cross multiply. We can put tangent of 32 over a 1 and just cross multiply. We know x times 1 is an x. Then we're going to have 25 times the tangent of 32. We know x is on a side by itself, so we can already just put this directly in our calculator. So going to our calculator, you just type in 25 tangent of 32 and press enter. Again, this answer wants it to be to the nearest tenth. So x is equal to 15.6. And we know the units here are feet, so we can go ahead and put 15.6 feet. Let's take a look at our last example here. A plane flying at an altitude of 10,000 feet begins descending when the end of the runway is 50,000 feet away. Find the angle of descent, depression, to the nearest tenth of a degree. So what I want you to do here is hit pause and try to work this one out by yourself. So first identify what type of angle you have, set up your triangle, and try to solve this. So take a few moments, hit pause, and try to complete this video or this problem by yourself. All right, so the key here is the angle of depression. So that airplane is up high, it's in the air, it wants to come down and land. So that means the line of sight is downwards, your horizontal is at the top, it's an angle of elevation, or sorry, angle of depression, and your 90 degree is also at the top. We need to talk about our sides. First thing they tell us is the altitude is 10,000 feet. Altitude, we know, is another word for height. So we have 10,000 feet. It's 10,000 feet in the air. It begins descending when the runway is 50,000 feet away. So the plane, position-wise, is right here. So if that plane was on the ground, which we know the runway would be down here where it's trying to land at the end, we know the distance from the airplane to the runway is 50,000 feet. So this is kind of like a rectangle being set up here. Well, actually, it is a rectangle. So the top, or the horizontal, is still the same on both sides because it's congruent. So looking at our triangle there, we need our angle of depression. There's our 90 degree. 50,000 feet is at the top on the horizontal, and we know 10,000 feet is our vertical. So we're standing at that 90, we're standing at the angle depression, sorry, not the 90 degree. Across from our 90 is our hypotenuse. Across from us is our opposite, and next to us is our adjacent. So the trig function we're dealing with has an O and an A involved. So if we think back, we have sine, which is, opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse, and we have tangent, opposite over adjacent. So we know O and H is not correct. We know C and A is not correct. So O and A is what we have. Tangent of theta equals opposite over adjacent. We don't have the angle, so we leave theta in the problem. We have our opposite, that's 10,000 feet, all over our adjacent, which is 50,000 feet. We know anytime we're solving for an angle, we hit inverse. So we need to take the inverse of tangent of 10,000 over 50,000. So we grab our calculator, we hit second tangent to give us the inverse, 10,000 all over 50,000. And we press enter. And this also wants the answer to the nearest tenth of a degree. So theta equals 11.3. Okay, so for all these problems, you want to first give yourself a visual so you can help identify where your angle of elevation and depression is. Label your sides, and then figure out, are you solving for a side or an angle? If it's a side, you cross multiply and solve for your variable. If it's an angle, you take the inverse of whatever trig function you have.